Now it should be fine, right? Awesome. Hi everyone, again it's me, and I'm Tarlan Huseinov, Senior DevOps Engineer from OpsLead, also one of the community leaders. And today I have the privilege of sharing the stage with yet another Huseinov, Kamran Huseinov, which is a graduate of our university, and he's also my colleague in OpsLead, and he's the AI engineer. So, could you please launch the second presentation, and we can kick this off. Our talk is going to be around the Agentic AI workloads and the evolution of AI. So, let's wait for the presentation to come up. Yeah, here we go. Awesome. And so AI and artificial intelligence today is one of the technologies that are moving the fastest pace ever that we've seen if you compare to any other piece of technology. And like the pace of wave and how the things change are really astonishing if you compare to the last era of technology. As anything else in IT, but specifically AI is the hype, and one of the most exciting directions is agentic airflows. And systems that don't just answer to our questions, but actually don't just, we don't utilize them as simple assistants as we used to a few years back. Now we're actually granting more and more access to our solutions, even to do the, not only to just provide us answers, but actually take actions against the daily systems, against everyday tooling, against our infrastructure, at some point to write our email, or filter things for us, create grocery list, and similar things that actually affect our lives. So AI is taking more and more kind of in form of an operator rather than an assistant these days. And so this thing that you see on the screen, the diagram is Gartner chart. It's called Gartner Hype Cycle Chart. And Gartner is the company that is a global research and advisory company. And they popularized this framework to show how emerging technologies rise through the hype and then crash into disillusionment, as you can see, and then they live up to the actual production use, actual productive use. So as you can see, agentic AI is on the top, is on the peak of inflated expectations, which is the reality, and we have to accept that. Whereas in reality, if we will be honest, there are a lot of problems that we need to solve before we settle our expectations. So AI is promising, AI is coming with huge promises, but there are a lot of problems related mostly to the cost, to the infrastructure, and reliability, and this is the things that we're going to touch mostly today. And let me switch to the next slide. And as you can see here, as the name refers, we're going to visioning one of the solutions that actually I've been going through the solution personally at the very beginning of this hype. And you see that we have a lot of options here in terms of where do we run the agentic AI. Where do we run this, where do we deploy this, how we operate them, and how we develop and build them. And you see, we have a lot of options. We can see that there's a containerization there mentioned. We have the classic stack, and we have the serverless stack. And all of these are actually the answers where we can deploy this infrastructure, the agentic AI, or any kind of solution. The only common thing that we have for all these three options, or even more options, is that all of them are deterministic. That means that the server, the VPC, the subnet, containers, Kubernetes clusters, either on AKS mode or on Fargate, serverless, everything has a common pattern. They are deterministic. So you give the input, you get the output. They are linear, they are predictable, and they assume that your workloads are going to be at least somehow predictable. So you can monitor them, you can track them. But the nature of AI and agentic solutions is totally different. AI is more relying on is more like a probabilistic rather than being one-liner. And this is the actual metaphor that we are trying to run non-deterministic workloads on deterministic infrastructure and hope for the best. And most of the problems that we're having today in terms of as a cloud engineer or as an AI engineer are really stemming from this fact that we are trying to run non-deterministic solutions on deterministic infrastructure, and we will be elaborating on that more closely. So when we collide these both worlds, we get the friction, and we need to experiment in order to find what matches our solution. This is like we're living through the most exciting phase of this technology, because in the experimental phase of doing things and trying things rather than knowing things, because there is no standard defined for AI workloads that you should run it on Kubernetes, you should run it on serverless, or you should run it on your servers and monolithic stack. So we are free in this chaos, and amount of possibilities are guiding us through this process. And so in this diagram, which is the kickoff of my own experience with Agentic AI, as a DevOps engineer, I would love to go and to play the Frankenstein and to create my own digital equivalent so that it can help me throughout the process for the cloud tasks, for cloud-based tasks, for DevOps automation-related tasks. And the very first idea when it hit me was about using the simplest, the no-code, the low-code, easiest option, because DevOps, as any other automation-related profile, that is software engineering, platform engineering, we are the laziest bunch, and we love to automate stuff and leave it to be and never touch it, so we can dedicate our free time to more different activities. Like it can be gaming, or it can be self-development. The latter one is the preferable, but the first one is enticing. So that's the main motive of many of the workloads that are created and we live by today. They are driven by laziness. So my laziness guided me to find the most no-code solution ever back in the day, and it was a thing called N8N AI automation tool, where I would love to get all the benefits of the cloud as well. So that was the very first iteration of the solution, where I have a DevOps agent that knows what I know and thinks how I think almost. I happen to be smarter at some point, and then it has the access to all kind of knowledge that I'm possessing within an organization in terms of documentation, Jira tasks, issues, problems, our goals within a company, the threads in the chat platform that we're messaging each other about a specific problem and solution of that problem, which is mostly about creating the right solution and informing your workloads about the status of your organization. So it can take actions, it can guide me through the problems, it can historically refer those problems and even decide some things that are very critical to decide based on some alerts potentially. So literally cloning myself into a digital form. And this is what I come with. There was a pendulum swung between the code-heavy solutions and low-code solutions, and now we're back for the more code-oriented solutions nowadays due to the maturity of AI solutions and the expected functionalities and requirements as it evolves with every single day. Here I'm going to walk you through this diagram, which actually has to be very simple, but at first glance it might be looking very overcomplicated. So here I'm basically utilizing an ECS cluster. So you grab a boilerplate template or CloudFormation template or Terraform template, and just go and click around in your configurations through the console to create a container, literally, on ECS cluster with some Fargate-backed ECS tasks, and you deploy N8N workflows there. So N8N is very famous. It has a SaaS solution, but as I want to make use of the security, seamless security, IAM policies and roles within the AWS context, I'm preferring to use self-managed within AWS Cloud. And we're dropping a container, we're integrating and giving it the correct policies, IAM policies, so it can have access to Bedrock LLM and Titan V2 model, which I'm going to talk about as well. And it has all the access that it needs, and from network perspective, I'm granting access to whitelisting from security groups, so it can interact with the wall key, which is just a Redis fork, open source Redis within AWS. And this is the cheapest solution, actually. So, and on the below side, this is the very first slide is just the platform itself. I'm provisioning the platform, and then I have the rack ingestion pipeline. So, in 2 words, rack is, for those who don't know about or haven't heard of it, it's just a system, a technology, a terminology that we use to pass all the information that I just mentioned to the LLM, so we can retrieve it on demand. So we don't have to retrain the model, and we just pass the documentations, the Slack message history, in a specific format, of course. We chunk them, we index them, we put it in a data store, which is a vector data store, and then based on the demand, our client is going to, by using the database search engine, vector store search engine, is going to go and do the similarity search and cosine search, all the technical stuff that is not that much interesting, but it's very easy to implement, especially on AWS. And so this pipeline here is based on some schedule. I'm provisioning a Lambda, which we just discussed, and that Lambda function actually will go and store some metadata in DynamoDB, and it's going to go and fetch the data from Confluence. It's going to chunk it and pass it to the vector store. Like every day, 2 times a day, or 3 times a day, you can just put a cron there within the event scheduler, and it's going to do iteratively go over your files and literally dump them to the vector source. So whenever your LLM, which you're going to see in the next screen, so this is how the workflow works in N8N. You have nodes there, and nodes are very similar to no-code components, or sometimes you can actually define them yourself. And this is very similar to nodes, as we said here, step function steps, or it can be a DAG, as from Apache Airflow, where you define the DAG. These are just steps that you define, you input and output data. You don't do anything specifically. You just grab some community nodes, some core nodes from within the N8N that is provided to you, and you literally provision this thing by clicking around. You don't do anything else. You just say that I'm going to get information from Slack, integrate it with Slack application, and then I'm going to read the information about the user, whatever it is, his ID or her ID, and I'm going to pass it further. I'm going to put some prompt, system prompt, as you can see, Bedrock prompt processor manually there, and we'll go to the AI agent. This whole thing is just a click around. There's no code here, no infrastructure code, nothing. Literally by clicking around, you can do it in 1 hour. And here we can see that AI agent actually integrates with the Redis chat memory. So you get a built-in memory, very simple, very configurable, but simple yet memory for your every session. You can configure how many messages you're going to have there, how you're going to summarize it, just in 2 clicks. And then we integrate it with by clicking around with the Bedrock, and if you have seamless access, you just click around, say that this AI agent is linked with this LLM, and with this Pinecone vector data store to store all our chunks, all our indexes that are coming from, Confluence. And that will be it. This is the whole, effort that you have to put into that solution. But the thing is, it didn't solve the problem. It's very black box. In order to do some custom integrations, you have to define your own nodes. You have to bring some Lambda nodes as well, potentially, to make it look as I would like to. What I would like to do is, like, I'm given a context, it creates based on the Jira ticket, or based on my message, AI agent can create a Kubernetes cluster and imitate the problems there so I can play around, for instance. And for that scale of solution, this is not appropriate because it's very black box, but for basic simplistic workflows, this is the way to go. I'm never advocating against it. So the very next iteration about the same solution is about Bedrock Agent. So what is Bedrock Agent? As you can see from the previous screen, some stuff has changed here because now I'm going to do some Bedrock managed services in order to accomplish my task of Frankensteining myself. And here, the thing is there is no no-code or low-code solution. I have to define some code base, especially for Slack integration. So you put the Slack part as a serverless stack, like event bridge, Slack handler, you integrate it with Slack API so you can message your solution, your Bedrock agent, and it will literally interact with the Bedrock agent and back and forth, intermittently transferring the outputs and back to your thread or direct message, depending how you interact with your Lambda function. And that will be all integrated with Bedrock agent. And from this part, you don't need to write any code. There is no code here again. It's totally managed, and you can integrated with the LLM seamlessly within the console, again, or infrastructure as code, and that thing will be working as well. But again, ambitiously, I want to create infrastructure using it, right? I want it to do my tasks, to have access to Kubernetes cluster, to have access to AWS API, to change things as I approve it, right? It's some not only read-only access. So in that case, we have action groups, and that action groups is actually the seeds of the MCP style interaction. As it's not like fully MCP, it's something that is in development at the moment, but you can still do similar API calls or create, for instance, DynamoDB table or put some data into your database, and that kind of task can be accomplished by using action groups. It's simply a big lambda with multiple functions. You define within the context which, it's like tool calling. You define in the context which function is going to be used for specific use case, and you put it into the chat, and it's going to be delivered. It works seamlessly, it works it really literally solves all the problems that it should solve. And you can integrate it another Bedrock functionality, which is called knowledge base. And knowledge base is simply a managed RAG pipeline. I don't need to create any ETL pipeline anymore, transform the data from one point to another. I just put the data into a stream, Bedrock knowledge base comes and chunks it based on the configuration that I'm defining, standard dimensions, or you can change the dimensions, and it puts it to the dedicated data store that you're defining, literally within the configuration. So you don't need to write any code, you just need to configure the service, and Bedrock knowledge base is going to work just fine. And as you can see, the only code base here is in the Lambda stack handler or any other client that you want to integrate. And still, this is the solution that actually works, by the way. It's still there. I haven't dismantled it, but anyway, it seems that this is not literally what I wanted to do. I wanted to be more flexible. I wanted to be able to add more functionality. I don't want to rely on Lambda actions, for instance, especially for huge ambitious plans like creating a cluster or S3 buckets and putting data in it. It has some issues in that scale. So this is why, while I was thinking of how I can upgrade this, AWS released a thing called Strands Agents in May in preview mode, and that's a production-ready SDK built for production, basically. And the thing is, it was so awesome that I had an experience that I have to redo everything from scratch and write some code again. And again, as I said, we're going back to the code-based solutions rather than having the managed solution. And what is very nice about Strands Agents, I would like to emphasize, is that all the heavy lifting is within the code base, but you don't need to write hundreds of lines there. It's just about few lines that does exactly the thing that I need from it, and it integrates very seamlessly with all the tooling that I want to, put in place as the idea, which is MCP servers right there within the code base or as another container potentially. So we embrace this whole solution again in ECS on Fargate, serverless. So ECS, Fargate is the serverless platform for Kubernetes and ECS, so you can make use of, so you don't have access to the machines, but it runs for you. You don't have to adjust anything other than configuration again. And there is a thing called CC API MCP from AWS. You can utilize it as well. You literally, based on the context, passing your request to the MCP server using Strands. Strands just provisions the whole infrastructure for you because it interacts with the AWS control API directly. And you don't have any limitations on that. It's the same thing that works underneath the cloud foundation. And by approving the infrastructure, it will spin up and destroy and list and do whatever you want with the infrastructure, which helps a lot. And I would name this the OpEx solution. And the RAG ingestion pipeline is the same. It never changed. We're still using managed RAG as a service by Bedrock. But the only thing that changed is we're using now Strands Agents, which is a totally code-based. And you could say that the mission is done. It's totally finished because we reached our goals almost, but we haven't answered to the question of friction between two worlds, where I said we're still deploying all this thing on a deterministic infrastructure. It's just a simple container. It's still an ECS server, and it's still deterministic, and I don't know how this project is going to evolve in the future, and I don't know if I'm going to overhaul and reiterate over this thing again and change the whole infrastructure based on my project as it evolves, because I don't know what's going to happen yet. I don't know how rapidly my LLMs and models are going to shift, because models are shifting, data is shifting, user behavior is shifting. I don't know where this is going to end, because within 3 months, I would like it to be production, but after 3 months, the whole picture is going to change, as you've seen, that it's very hard to track everything in the AI world. It's like, it feels like a full-time job to be on the edge solution. So that is why, as soon as I was about to finish all this thing, AWS again did their thing and released another thing called Agent Core. And Agent Core, in my opinion, is simply the answer to most of the problems, and especially to the friction problem, because now, despite it still being a managed service and deterministic, now it has everything within a small box, every solution, everything that you need is going to be in the small box, and there is no chance that the requirements that you will have in future will not be integrated into that box. So you will have all stuff that you need within that box potentially, and there's a minimal chance of going back and destroying the whole infrastructure and switching to something new. Because in that case, that wouldn't make any sense. So it's still deterministic, but because of the flexibility, I would call this, that's the apex solution. And at this pace, I'm going to pass it to Charman, who's going to walk us through the Agent Core and explain how Agent Core will take everything and level it up even further.